Okay, I was going to go ahead and make a quick video of the last part of that linear regression Moodle assignment. I'm having to use a different Zoom account because something's gone crazy with OCCC's accounts right now. So I'm hoping that this is going to look okay. But what I wanted to do was go ahead and go into the Moodle assignment and kind of go over the answers that we should have gotten up to some point. So I think there's 6 questions altogether. I'm going to kind of rip through them all and then kind of explain 4 through 6. So if you look here, this is the table that we're being asked to put into Desmos, and it's got, it says something about the years after 1990. So that means 1995 would be 5 years. So the X values for this left-hand column would be 5, 6, 7, 8, 9, and 11. And then the output or the Y values would be those numbers that we see there. So if you look at the Desmos, I already have that table in there. To start, you have to click the plus sign and then add a table, and then you type in your values. Notice when it's just individual plotted points, we're dealing with, they call it X1 and Y1 when we're talking about coordinates for data points. All right, then underneath that, I did a linear regression based on these two, where I want the Y values over here, the second column, to be functions of the input values or the years. So this is how you type that. You have to use the same labels up here, X1 and Y1. And then instead of an equal sign, you use the little tilde signs kind of next to the 1 key on your keyboard. It's probably down here too, somewhere. I think there's a tilde. Well, I don't see it, but I'm sure it's down there somewhere. Anyway, so that when you look at this, the M value, your regression slope is going to be the 83.4491. The B value, which is the y-intercept, or that's like what it would be when x is 0, 4873.6. That doesn't have very much detail to it, just 1 decimal. So if you need to see more decimal places than what's showing when they show you the parameters for a regression, just type in the letter that you would like to see more of on the next line, and it will expand it and show you the extra points down. So let's go and answer the questions. You go through here. Let's go to question 1. It wants us to go down here and do a linear regression, use a linear model. X is years after 1990. So we're going to put that into Desmos, which I have already done. And it says, find the slope of the linear model that comes up in Desmos, rounded to 3 decimal places. Okay, so the slope is this M value, 83.449. If we round that to 3 decimal places, we're looking at the 9, and we're going to keep it at the 9 because it's followed by just 1. So 83.449 would be our slope, 83.449. And then it'll tell us some feedback down here. Response is nice. So I guess I got it right. Let's go to the next question. Same statistic, but they want it to talk about rounding to 3 significant digits, which of course is different, or what's sometimes called significant figures, depending on kind of what class you're in. So it's not decimal places. There's a type in which it's places. Significant digits. So that means reading the number from the left to the right, the very first non-zero number that you come to is the first significant digit. And then we're also going to look at the 2 digits that follow that. So if we go back and look at the slope, the very first number, it's a 8. So that's my first significant digit. So the 8 and the 3 and the first 4 are 3 significant digits. So I need to know how to round that 4 by looking at what follows it, which is another 4, which means the first 4 should not round up. It should stay there. So 3 significant digits on this number would be the 8, the 3.4. So 83.4. It's 3 significant digits. See, 1, 2, 3. So we will submit that. Good is my response. So let's go for question 3, and then we'll get into the ones you were asking about. All right, so significant. Now we're asking about the y-intercepts. That's our B value of the model. So rounded to 3 decimal places. Okay, we couldn't see 3 decimal places in the original regression report. So that's why on the next line I went ahead, if it hadn't been there. If you need, I need more accuracy than when it's showing, I just go to the next one. I don't have to type an equation. I just type the letter that I'm interested in that's already been defined up here. And we can see that it's not just 0.6, it's 0.6005149. So I think it said 3 decimal places. So that would be the 6 and first 0. The second 0 is the one I have to decide whether to round up or leave it 0. It is followed by the 4th decimal place is a 5. And of course, if something's followed by 5, 6, 7, 8, or 9, we're supposed to round it up. So that second zero is going to bump up to a 1. So 4873.601. 4873.601. Okay. Now this is what you were asking me about actually, was when we get to question number 4. Okay, so here's our data. Use this data to find the linear model. Same, we've already done that. Same question with different rounding instructions. So the y-intercept rounded to 3 significant digits. All right. This is a little tricky because if you look at it, 3 significant digits doesn't even get you down to the ones place. The first significant digit is a 4, and then 8 and 7. So the 4 and the 8 and the 7 are 3 significant digits. I can't just write 487 because that looks like 487. So what you do is anything after that, I need to put one more digit down there so that I know that the 4 is in the thousands place, and the 8 is in the hundreds place, and the 7 is the tens place. And I only need 3 significant digits. So any other digits that I need to fill in to make the number have the correct place values for the digits, I just have to use a 0. So I just need 487, and then I do need one more digit after that, which is going to be a 0. So it'd have 3 significant digits, but it would still be the 4, it means 4,000 and something. If I just write 487, that's 487, and it's 4,807, and everything else is a 0. So 4870. So anything between the decimal place and your significant digits, you fill in with zeros. So 48370. So my significant digits are the 4 and the 8 and the 7, but I need one more digit because I'm in the thousands. Hope that's helpful on that one. So let's look at the last two. Okay, now it says use an unrounded model to estimate the percent of the population category A in the year 2000. Okay, so to do their unrounded model in Desmos, you don't want, let's go back here, and we need to use it like a function so that we can plug in 10 for the year 2000. So I don't want to just use these numbers and write a function like f of x equals, or y, I guess f of x equals. I don't want to write this number times x plus the 4,873 because those are rounded values. I want to actually use what the calculator is storing as all of the significant digits that it had for those two values. It's just showing us rounded values here. So I'm just going to use the same variables, m and b. I'm going to write it just like this, except I'm just going to use x instead of x1. It's not a regression, it's an actual function. So I'm just going to use the letter x, but I'm going to write mx plus b. Now, when I do that, it's not just going to think of m as 83.4491. It'll think of m as whatever the other digits that are after this that it just didn't show us. And the b value, like I had talked before, it's not just 0.6. Remember, it was 0.66009 something or other. It's going to use more accurate values. So now that I have put that function in, and you'll notice that it's in green and it graphs right on top of all the points. So that does seem to be the one that came from the functions. Now I want to figure out what it is at 10. Now I think didn't he suggest using a table here? Well, he didn't suggest using a table. So I just need to plug 10 in somehow. So we can make a table and type in 10 into the table, or we can just do f of 10 and use our function notation. That's another way. It'll just display the answer right there. If I wanted to do a table instead down here, I could, what do I do here? I think I go up here. You click, where do I click? This one? No. How about, is it here where we add a table? No. All right, I'm not going to mess with it because I can't think of it off the top of my head. And I know that this is one way you can plug in an input and get an output is like this. I'll figure out where the tables are later. Okay, so what is the answer? The year 2000 would correspond to an x value of 10. We're going to plug it into the general function definition with the m and the b, because that's going to give us our unrounded values. So it's 5708. Was it to 3 decimal places? Round to 3 decimal places. Okay, so it's 5708 0, 9. The 1 is the third place, but it's followed by an 8. So the 1 bumps up to 2. So 5708.092. 5708.092. Let's see, my copy there. Okay, that's it. So I think we're on, what question was that one? Well, we'll see. Oh, that was question 5. All right, so let's see what the last question is. It is use Dan rounded model. So we're still going to use that one. I called that f of x to estimate the year when 7,161,000 individuals in population will be in category A. Okay, I think on this one, it would be easier to do what we've got here and solve it graphically. So I want to know when the output is 7,161. So if I just take that with the graph of the regression equation and shoot a horizontal line over it that has the height of 7,161, then Desmos can spit out that intersection point really quickly. So let's see. So let's go over here. I'm going to do y equals, I've already forgotten the number, 7,161, 7,161. You can see it's, I can't see it on my page here. I guess, I don't know, 0 to 15, 0 to 15. But if I'm just clicking and dragging my graph down here. So, oh, sorry. 7,000, what was it? 161. 7,161. Okay, so see how it shot that line through the picture there? I may have to, I'm just clicking and dragging my screen across. So the green line was the regression equation. The blue line is all the points that have a y value of 7,161. If I click on the graph, it will show me that intersection point right there. I'm having to hold it down, but see the 7161 is the y value. And then the x value is what we're interested in. So just under 27.5 years. So this is finishing the year, what, 2027, and we are now 0.42 of the way into 2028. Okay, so when you're using x values that are between the whole years, when they represent years, we generally round up because it means we have finished the year in front of the decimal and we're partway through the following year. Okay, so it says in the year, what would it be? What did we say? 20,000, it was 28, right? Let me look one more time. Yeah, the 27. Oh, let me get in there. Where's it? There it is. So now I don't know why I couldn't get the little gray point. So the actual intersection point in gray is when x is 27.411. So that's going to round up to 28. So our year will be 2028 because we have to add it to our start year. Let me see how I did. We generally want to round those up. No, it doesn't like that. Use your Desmos graphing skills and round the year up to the next year. Well, I believe I did, Daniel Benton. All right. Oh, it's 1990. All right, so that would be 2008. Right. Instead of, I'm doing it by 20 years, so that would be 2000, so it's 2018. Sorry. So I did that wrong. 2018 is what it should have been because I was trying from the wrong start year. 2018. 2018. Let's see if I get it right this time. Yeah, I was off by, congratulations. Did it grade my problem? I can't tell. Well, anyway, that's how we do the problems. I'm going to go ahead and stop this so I can send it to you. Let me know if you have other questions.